Hello students, welcome back to Quick Coaching. Today we are going to start a new topic, mathematical tools. Is a very important topic in JEE Physics because if you do not know the mathematical tools, it will be very difficult for you to solve the difficult problems in JEE Advanced or JEE Mains. So today we are going to be acquainted with the different mathematical tools that will be used in JEE Physics. So the first theorem that we are going to use is the binomial theorem. Binomial theorem. Now, the binomial theorem is a separate chapter in JEE Mathematics, but I will only do the portion which is required in JEE Physics for now. So, what does this theorem state? If n is any positive or negative integer or a fraction and x is any real number, then we can write 1 plus x whole to the power n. 1 plus x whole to the power n. This can be expanded as a series according to the binomial theorem, which is given as 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x cube and so on, where we know that 2 factorial equal to 2 into 1, 3 factorial equal to 3 into 2 into 1. In general, n factorial is equal to n into n minus 1 into n minus 2 up to 3 into 2 into 1. Now, if mod x is much less than 1, that is, in this expansion of this series, 1 plus x whole to the power n can be expanded as this according to binomial theorem. Now, if mod x is much less than 1, which means that x is a fraction. Now, if x is a fraction, then higher powers of x, that is x square, x cube, will be very small compared to x and 1. Therefore, the higher terms can be neglected. Thus, we can write this as 1 plus x whole to the power n equal to 1 plus nx approximately, because these higher order terms are very small compared to this. So, if we neglect all these higher order terms, it will not make much of a difference to this series. Thus, this series can be approximated as 1 plus nx. Now, this will be a very useful result in many physics problems. So, we must try to remember this series and this approximation. The next important topic in mathematical tools is logarithm, because this is a topic which will be used in different aspects of physics as well as mathematics. So we must know the basics of logarithm to progress in physics or mathematics. So the first formula in logarithm is log mn base a. Mn base a is equal to log m base a plus log n base a. This is the first formula. So we can write, I'll give you an example. If it is log 10 base 6, we can write this as log 10 base 3 into 2. So we can write log 10 base 6 is log 10 base 3 plus log 10 base 2 according to this formula. So this is the first important formula that we must remember for logarithms. The second important formula is log m by n base a is equal to log m base a minus log n base a. Now similarly, if we have, I'll give you another example. If we have log 10 base 3 by 2, then we can write this as log 3 base 10 minus log 2 base 10 according to this formula. Number 3 is the power formula, that is log m to the power n base a can be written as n log m base a. That is, the power comes in front of the logarithm m base a. This is also very simple. If we have, I'll show you an example. Log 10 base 9, suppose, and we can write this as log 10 base 3 square, and we can write this as 2 log 3 base 10, sorry 3 base 10. Now our next formula is base changing formula, that is log m base a can be written as log m base b into log b base a. This is also a very important formula which must be remembered. Okay, so this is the major part of logarithm. There are two more formulas which will be very useful. I'll show you those also. This is one of them. This is similar to this formula. This is similar. This is an application of this formula. Here the m comes in front according to this formula, m log a base a. Now we know that log a base a is equal to 1 for any number a and a. This is 1. Okay, so we have m. We will have m, this equal to m. Number 6, which is another very important result. This will be one of the most important results. It is a to the power log m base a. A to the power log m base a. This is equal to m. Now I will give you an example. Example is suppose 3 to the power log 3 base 4. Then this will be equal to 4. So this was all about logarithms. I will show you the formulas once again. The first formula, log mn base a is equal to log m base a plus log n base a. I showed you an example. Log 6 base 10 is equal to log 3 into 2 base 10, which is equal to log 3 base 10 plus log 2 base 10. Now our second formula was log m by n base a is equal to log m base a minus log n base a. Now I showed you another example of this formula. Now the third important formula was log m to the power n base a is equal to n into log m base a. Now this is a very important formula which is to be remembered. And number 4 was the base changing formula, which was log m base a is equal to log m base b into log b base a. And number 5 was log a base a to the power m base a is equal to m into log a base a. Now log a base a is 1, therefore we have this thing equal to m. Now the sixth important formula was a to the power log m base a, which is equal to m. Now this is an example of this formula. Now I have showed you all the important formulas of logarithm. I hope you will write these down on a notebook, which will help you further in future problems. Now our third topic today is differential calculus. This is the most important topic in JEE Physics. This is because every problem in class 12 or class 11N deals with differentiation or integration. So if you do not learn this properly, you will not be able to solve any problem in competitive exams. So this is very important to learn. So I will advise you guys to take a notebook and write down all the notes that I am going to write here. So I am going to start with differential calculus. What is differentiation and where to apply differentiation and why do we use differentiation? These things will be clear from this lecture. So what is differentiation? First we may take a function y equal to f of x. This is a function. This is a curve y equal to f of x, which can be drawn on the graph. So this is the x-axis, this is the y-axis, and we draw an arbitrary curve like this. This is y equal to fx. Suppose this is an arbitrary curve. Okay, now if x increases by a small amount, then y also increases by a small amount or decreases maybe. So whatever, if x changes, then y changes. Thus del y by del x is equal to the average rate of change of y with respect to x. Now what is del y? Del y is the change in y and del x is the change in x. If we change x slightly, the value of y also changes according to the function y equal to fx. because if the value of x changes, then we put it in fx, then the value of y also changes. So del y divided by del x is the average rate of change of y with respect to x. Now if we consider that limit del x tends to 0, which means that the change in x is very small, the interval is very small, so it becomes infinitesimally small, then del y also becomes very small. So we can write limit x tends to 0 del y by del x as dy by dx. Now this dy dx is termed as the differential coefficient of y with respect to x, or the derivative of y with respect to x, which means that this is the differentiation of the function y equal to fx with respect to the variable x. Okay, now this gives the instantaneous rate of change of the function y with respect to the variable x. Now what does that mean? That at every instant the change in y with respect to x is given by dy dx. Now there is another application of differentiation. If we consider this point and we draw tangent to the curve at this point, then if this angle is theta, the slope of the tangent to the curve at that point is theta, and we know that the slope of the tangent at this point is equal to the slope of the curve at that point. So the slope of the curve at this point is tan theta. Now if we consider a very small change in y in this neighborhood, such that this change in y is dy, this small change in y is dy because delta y tends to 0, and this small change in x is dx because delta x tends to 0. We have considered here that delta x tends to 0, so the change in y will also be very small. So if delta x tends to 0, this is a very small change in x, that is dx, and this is a very small change in y, that is dy. Then from these two parallel lines, this is parallel to x-axis, so we can write this small angle as this small angle which I have shaded here, this small angle as theta, because these are corresponding angles. So we have this as theta, this also as theta. Therefore from this triangle we can write that tan theta, from this triangle, this small triangle I have drawn here, we can write tan theta is equal to this small length divided by this small length, that is dy by dx. Therefore we have derived a very important result from here, that is the slope of a curve at any point is given by the derivative of that curve y equal to fx with respect to x at that point. Thus these are very important results which have been derived here. Now there are some important formula for differentiation which will be very handy. So you have to remember all the formula, memorize them so that they are on your fingertips, such that you can differentiate any function given to you. Now I will summarize what I have taught you just now. If you are given a function of x, y equal to a function of x, such that if x changes, y also changes. So if x changes, y changes, then delta y is the change in y and delta x is the change in x. Then delta y by delta x is given as the average rate of change of y with respect to x, and if limit delta x tends to 0, that is the change in x is very small, then delta y by delta x changes to dy dx, which is the differential coefficient of y with respect to x, that is the differentiation of the curve y equal to fx with respect to x. And we derived another important result, that is tan theta equal to dy dx, that is the slope of the curve at any point is given as the dy dx of the curve at that point, that is the derivative of the curve with respect to the dependent variable at that point. Now I have written down some important formulae for differentiation which will be very handy in differentiating a curve or any function given. So the first formula is, if c be a constant, then d dx of c equal to 0, that is the differentiation of c with respect to a variable x is 0. Now how can this be graphically understood? The proof to this is like this. If c be a constant, we have y equal to c and we are doing dy dx, that is d dx of c. dy dx equal to d dx of c, which means that it is the slope of y at any point. d dx, we just now did tan theta equal to dy dx, which means the slope of y at any point, which is equal to d dx of y, that is d dx of c. So this is the curve y equal to c, where y is constant at each point. So the differentiation of this curve is 0. This is because the slope of this curve at any point is 0. the slope is constant and the slope is 0. So the ddx of c is 0. This is the graphical interpretation of the differentiation of a constant which is equal to 0. And then comes ddx of x to the power n is equal to n into x to the power n minus 1, where n is a constant. That is, if we have ddx of x cube, then this will become 2 into x to the power 3 minus 1, which means 2x square. Now if we have y equal to u plus minus v, where u and v are not constants but they are functions of x, that is u depends on x, v depends on x, then if we differentiate y dy dx, then we have equal to du dx plus minus dv dx. The fourth formula is ddx of ln x. Now what is ln x? Ln x is log x base e. Now this is a very important thing to remember. You will find this notation in many books. So ln x is log x base e, and the ddx of ln x is 1 by x. Now number 5 is ddx of e to the power x, which is equal to e to the power x. It remains same on differentiation. Now number 6 is ddx of a to the power x, which is given as a to the power x log a base e. Number 7, ddx of sin x equal to cos x. And number 8, ddx of cos x equal to minus sin x. Now we have more formulae. ddx of tan x is sec square x. ddx of sec x is sec x tan x. ddx of cot x is minus cosec square x. And ddx of cosec x is minus cosec x cot x. So I would advise you to write down all these formulas on a notebook, because if you do not remember these, you will not be able to differentiate any function given to you. So here are some of the basic formulae that will be used in mathematical physics, and I would like to tell you that you will study differentiation in detail in mathematics. Now these are the formulae that will be required in physics. So I have written down all these formulae for your help. There are 2 more important formulae that I will write down later, but I will solve some problems based on these formulae first for your understanding. So I would advise you to write down these formulae and memorize them very well, so that you would be able to solve the problems. Now I will go through them another time. This is number 1, 2, 3, 4, 5, 6, 7 and 8. And here are number 9, 10, 11, 12. If you can pause the video and write down these formulas. These are our first 2 problems on differentiation today. Now we are given 2 curves, y equal to x to the power 5 plus x cube plus 10, and y equal to x plus root x plus 1 by root x. So we are asked to find out dy dx, or the differentiation of y with respect to the variable x. Now how do we do that? Now we know the formula that ddx of x to the power n is given as n into x to the power n minus 1. We just now did it. So we will use this formula to differentiate these 2 curves. Now y equal to, in our first problem, it is given y equal to x to the power 5 plus x cube plus 10. So how to do that? Dy dx is equal to ddx of this whole thing, that is x to the power 5 plus x cube plus 10. And we have done that if all these are functions of x or any function, then we can write this separated as this ddx of x to the power 5 plus ddx of x cube plus ddx of 10. We can write this. In our elementary stage I am writing this, but afterwards you can directly do it in your mind. You don't have to write this step, so it will be faster, but for your understanding I am writing this step. So we know that ddx of x to the power 5 can be done using this formula, where n is equal to 5. So the ddx of x to the power 5 is 5 into x to the power 5 minus 1, which is 4, plus ddx of x cube can be written as 3 into x to the power 3 minus 1, which is 2, and ddx of 10. Now 10 is a constant, and we know that differentiation of any constant with respect to any variable is 0. So ddx of 10 is 0. Therefore we have the dy dx of this curve with respect to x is 5x to the power 4 plus 3x square. Now what is our second problem? We have this function. So in our second problem we have y equal to x plus root x plus 1 by root x. Now this can be written as x plus x to the power half plus x to the power minus half. Now we can again use that formula, this formula, x to the power n, differentiation of x to the power n with respect to x is n into x to the power n minus 1. So we can write dy dx dy dx is equal to d dx of this whole thing. Now we can again separate the three terms, and then we have d dx of x plus d dx of x to the power half plus d dx of x to the power minus half. We have these three terms. Now we know d dx of x according to that formula, n equal to 1, therefore 1 into x to the power 1 minus 1, that is x to the power 0. Therefore we can write it as 1 into x to the power 0 plus x to the power half, therefore we can write this as half into x to the power half minus 1, which is minus half plus d dx of x to the power minus half, therefore minus half x to the power minus half minus 1, that is minus 3 by 2. Therefore x to the power 0 is 1, we can write this as 1. Now x to the power minus half is 1 by root x, therefore we can write this as 1 by 2 root x, and we have here minus half and x to the power minus 3 by 2, that is we have root x. X to the power minus half is root x cube, so root x cube, what is that? X root x. So we can simplify this and write down 1 plus 1 by 2 root x minus 1 by 2 x root x root x. Okay, so this will be the differentiation of this given curve. Now another important method of differentiation is the chain rule. So we are going to start with chain rule. Now what is this? Now dy dx is equal to dy du into du dx. Now what does this signify? Now here u is a function of x. Obviously u is a function of x and y is a function of u. That is, suppose it is given y equal to u to the power n, where u is a function of x, that is u depends on x. U is a function of x and we are asked to find out dy dx. Then how to find out? Dy dx is equal to, we will differentiate this now, this with respect to u, dy du. Now how to do that? We know this formula, therefore we have n into u to the power n minus 1, differentiation of this with respect to u, and then differentiation of u with respect to x, that is this multiplied with du dx. Thus this will be our answer. So this is the chain rule, that if y is given as a function of u, which is again a function of x, that is y is given as function of u to the power n, and u is again a function of x. Now we are asked to find out the derivative of y with respect to x, not with respect to u. Remember this. This is a point to be noted. We are asked to find out the derivative of y with respect to x and not with respect to u. Now here it is that the chain rule comes into play. Now how to find out dy dx? That is dy du, differentiation of y with respect to u, which is according to that formula we have found out, and then multiplied by the differentiation of u with respect to x. Okay, now we have found out dy dx. Now I will give you some examples so that you understand this concept better. Now the first example, our first example is y equal to root over 4x square minus 7, and we have to find dy dx. Now how to do this? Now here u is given as 4x square minus 7. Now we can write y equal to u to the power half. Now we are asked to find dy dx, not dy du, so we have to apply chain rule. Now how to do that? Dy dx is equal to dy du into du dx. Okay, now you can understand why this is so, because dy du and du dx, if du du is cancelled, then we get dy dx. So dy du into du dx. This is pretty simple to understand. Now and remember also, so dy du is half u to the power half minus 1, that is minus half, into du dx, Now we have u as this, so we can easily find out du dx. Okay, now how to find out du dx? In du dx, we have differentiation of this with respect to x and this with respect to x. Now differentiation of any constant is 0. So, and differentiation of this one will be 4 into 2x. 4 into 2x minus 0. So we have 8x. I'm directly writing down now because I think that you will be proficient with the formulas previously given. So we found du dx as 8x. Now we'll substitute u as a function of x and du dx as a function of x into this expression and we will get dy dx. So we have u as this 4x square minus 7. So 4x square minus 7 whole to the power minus half and du dx is 8x. So 8x. Now 2 and 8 cancels. Therefore 4x divided by 4x square minus 7 whole root. Now this is the answer of dy dx. Now I will teach you a very tricky method. Now this will be a very easy method to do the chain rule because if it will be very tedious if you have to every time find out the function u, then consider u, differentiate y with respect to u and then u with respect to x. It will be a very tedious method. So for bigger problems you will not get such time. So I will teach you a trick how to do the chain rule very easily and fast. Now our next two problems for today, I'll show you one problem. Now this is y equal to cos of ax square plus b, where a and b are constants. Now we have to find out dy dx. So we know the formula of differentiation of cos x, but we do not know the formula of cos of ax square plus b, where a and b are constants. So we have to apply chain rule here. Now how to do that? Now the fast trick for doing the chain rule is that we will differentiate and simultaneously multiply the differential coefficients at each step until we find out pure x inside the differentiable function. Now we are differentiating this function. Now inside the bracket it is not pure x but it is ax square plus b until we find a linear function, that is a function of x. Until then we have to differentiate. So what we will get now? Now we have this, okay. Now what we will do is dy dx is equal to cos of ax square plus b. So we'll first differentiate this and we'll get minus sine ax square plus b because differentiation of cos x is minus sine. So we have got minus sine ax square plus b and then we again differentiate the thing inside because it is not a pure function of x. So we will again differentiate this and we'll get 2ax because b is a constant, so differentiation of it with respect to x is 0. Now we have found out a pure function of x, that is 2ax. So we will stop here. Thus the answer is minus 2ax sine of ax square plus b. Now this is a fast trick to do the chain rule. Now here I have listed two more important formulas for differentiation. Where y equal to ue, this is known as the product rule of differentiation because y is given as a product of two functions u and v, where u and v are functions of x and not constants. So how will differentiate? Dy dx is equal to u into dv dx plus v into du dx. So the differentiation is given of the product of two functions. So this is known as the product rule of differentiation. And we have another rule where y is given as u by v, where u and v are functions of x. So this is known as the quotient rule because this is a division rule because this is the division of two functions of x. So we have the formula dy dx is equal to denominator into ddx of numerator minus numerator into ddx of denominator divided by denominator square. Now we have dy dx equal to v into du dx minus u into dv dx by v square because we have numerator equal to u and denominator equal to v. So we have substituted it here and found out dy dx. Here is a very simple example of the division rule. Now I am not showing an example of the product rule because if you understand the division rule, you will be automatically able to generate the product rule automatically. So how to do this? Y is given as a division of two functions of x. This is u, 2x plus 3, and v is x square minus 5. That is y is given as u by v. So we'll apply the division rule to differentiate this. So we have dy dx equal to denominator x square minus 5 into ddx of the numerator, that is 2x plus 3, minus numerator, that is 2x plus 3, into ddx of the denominator, that is ddx of x square minus 5, whole divided by denominator square, so x square minus 5 whole square. So we will substitute the values of ddx of 2x plus 3 and ddx of x square minus 5, that is ddx of 2x plus 3 is 2 and ddx of x square minus 5 is 2x. So we have substituted this and now you can simplify this expression to find out dy dx. So this is the example of division rule. Students, today we learned some mathematical tools which can be used in physics. and like binomial theorem, differentiation, chain rule, product rule, division rule of differentiation. In the next video we are going to learn integration and some other mathematical tools which can be very handy, and also see the application of differentiation in physics. So for today I am going to sign off, and I would like to ask you guys that how you are liking the video, or if you have some helpful suggestions then please provide them in the comments, and if you find this video helpful then please like, subscribe and share the channel. Goodbye guys, and best of luck for the JEE aspirants who are going to start this year. I am going to suggest more videos, start more videos on the topics of JEE physics, and I will also bring more videos on JEE maths. So keep following this channel, and I would love to get your support. So please give me some feedback in the comments. And for today, bye students, signing off.